When I think about lung cancer spreading throughout the body in a process called metastasis, I think about a lot of people inside of a house. You can imagine that with this many people in a small space, it's probably getting a little cramped, and resources like food in the house may become strained. Or maybe because of some other reason, like they just can, people are going to start to leave this home, and they're going to go out and find new homes to inhabit, settle down, and continue to multiply. In order to do this, they would probably have to use things like local streets and highways to leave their original location and spread out. So I want you to keep this in mind when I say that cancer cells act similarly, where cells might primarily live in the lungs, for example, at first, but then spread to other locations in the body, like the brain, bones, or liver. But in cancer, this spreading out is given a fancy name, and it's called metastasis. So if humans use roads to spread out, cancer cells use tubes called vasculature that are found throughout the body to travel around. So come on, let's look at this further. I've drawn a capillary bed, and since capillaries are found in tissues all over the body, I'm going to draw these hashtags in to remind you that capillaries aren't just floating around in space. They're embedded in tissues, surrounded by things like collagen and muscle and nerves and cells and proteins. So blood from the heart is traveling through this big tube, an artery. Think of this as a highway, and the blood is going to travel into these capillary beds that I think of as local streets because they're smaller than the highways and the blood isn't going to flow as quickly within them. But the blood will eventually connect back to another highway on the other side, called a vein, and return to the heart. But there's one other tube in all this that I always feel like doesn't get the attention it deserves. And so I'm going to highlight the awesomeness of this vessel now. It's the lymphatic vessel. And these vessels give very little thanks for all that they do. They do this significant job of collecting immune cells and protein-rich fluids that have escaped out into the tissue from the veins and arteries and funnels it all back into the veins. Well, I'm wondering if you can see what might happen if there's lots of cancer cells growing in the tissue here. And if you can't, remember back to the example of the people living in the first house. They left. For a variety of reasons which aren't well understood or known in cancer, these cells are going to invade the capillaries and the lymph vessels and use them to spread out in the body. So I'm going to show that with an arrow and an arrow. Now please don't forget that my champion lymph vessels, though they'll eventually join with veins, along the way they detour into lymph nodes. And these are specialized places throughout the body where immune cells can be exposed to proteins from invading pathogens that may be present in particular tissues. And this will trigger an immune response. But let's move this image up and go back to talking about the cancer cells that are spreading all over the body. The cancer cells traveling through the lymph vessels see the lymph nodes as their new homes, and they settle down here and begin to form a secondary site of cancer. Often this is the first place cancer cells will spread. So in lung cancer, the lymph nodes along the center of the chest are quickly invaded, and this makes sense because they're nearby the original site of the lung cancer. So cancer cells are floating around in the blood, and they can go to new locations like the brain or the bones and liver. This doesn't quite look like a liver, but you get the point. And in lung cancer, especially the adrenal gland, forming new homes or secondary tumors in all of these sites, which make metastatic cancers or cancers that have spread very challenging to fight because now you're battling cancer in multiple locations. This is why a significant effort from the scientific community has gone into understanding more about what makes cancer cells spread and how they actually do it so that drugs can be targeted to prevent this from happening and increase the chances that a cancer patient will survive.